Hi folks, Mr. Long here. I'm going to do a quick little lesson to show you how to calculate the average y value for a function. And it's a useful little calculation that you would need to have, you need to understand area under the curve to be able to do it. And it's, if you look at something like this, so the y value all along there is 3, and then it goes to 0, and then it goes down to -3, and then it goes across at -3, and then the y value climbs back up in a linear way up to y equals 3. And what we need to be able to figure out is what's the average y value, okay, the average y value. Now, a lot of folks would say, oh, well, yeah, it's easy to do. I'll show you an example here. So say we wanted to get the average y value for this graph. And we wanted to figure out, say that this was 10 and this was 0, and we wanted to figure out the average from x equals 0 to x, say, equals 4. And a lot of people would just say, okay, that makes sense. Just take the 0 and the 10 and divide by 2, and it's 5, right? The average is 5. Now, that doesn't make a lot of sense, because if you look at it, there's a lot of y values that are very, very low, okay? It doesn't climb up until we get to 10. And if you want to think of it this way, if you went across, now it's a continuous function, so it's a little hard to do, but think of it as if it was discrete, just a series of, just a series of points. No, there. If it was just a series of points, then what would it look like? Well, you'd have a point there at 0, and you'd have a point at 1, and you'd have a point at 2, and then you might have a point at 3, and then you have a point up here at 4. And if you look at that, you'd have maybe 0 plus 1, right? Plus maybe 2, plus maybe 4, and then 0, 1, 2, 4, and then 10. And if you get that average, well, 1 plus 2 is 3, plus 4 is 17, plus 10 is 17. 17 divided by 4 is like 4.2, right? So it's not 5. It's not the middle. And it's going to be a little lower, right, than 5, because there's more y values below 5. So we need a way to do this when things are nonlinear. If things are linear, absolutely, you add the bottom and the top and divide by 2. That's how you get the average. But in our case, it just doesn't work that way, nonlinear. And as we know, most relationships in math are nonlinear. Okay, so just to begin, this is the strategy we're going to use right here. So I'm going to give you a nice simple example. If you knew that that rectangle was 3 meters wide and you knew the area was 6, what would the height be? Now, I think most people are going to go, oh, it's 2, because 3 times 2 is 6. But if it wasn't a nice number and you couldn't do 3 times 2, how would you really do it? Like if it was 6.287 and the width was 3.199, well, you would have to end up doing 6 divided by 3 equals 2, right? Divide those two to get your length. And that's because base times height equals area, right? So the height equals the area divided by the base. Okay, area divided by the base. Okay, so that's this calculation we're going to come back to. All right, so here's a graph, and what we're going to do is calculate the area between x equals 1 and x equals 8, and then we're going to fit that area into a single rectangle that's also placed between x equals 1 and x equals 8, okay, in a single rectangle. And then we're going to get the y value of that new rectangle. So let's go ahead and do this. So I want to go from x equals 1 all the way to x equals 8. So let me get the highlighter out and highlight the areas. So I'm looking at this area, I'm looking at that area, that area, that area, and that area. Okay, those are all the areas that I have. Now there's something there, and I want to get the total area. There's a few things that I can do here. It's going to make my calculation really, really quick. That one is 6, that one is -6, so they cancel out. This one is 1, 2, 3, times 1 is 3, divided by 2 is 1.5. That's 1.5. This one is -1.5. So that cancels out. So that's gone, and that's gone, that's gone, and that's gone. Well, that means the only area I have that doesn't cancel out between 1 and 8 is this negative 1.5. So that's the net area between x equals 1 and x equals 8. By the way, the area from 1 to 8 equals, or whoops, f of x dx. By the way, we're going to call this function f of x. And that equals negative 1.5. Okay, that's the area. So what I'm going to do over here is I'm going to take that area. That area is going to equal negative 1.5. And I'm going to have this rectangle that goes from x equals 1 to x equals 8. So that means the width of this rectangle from here to here is 7. Right? And then I have to figure out the height of that rectangle. Okay? So I'm going to go over here and just show you what that looks like on the graph. So I'm going to go all the way across there to 8. Now, so it's some number multiplied by 7 is 1.5, or h equals negative 1.5 divided by 7. Well, if I want to get an approximate answer, by the way, I can divide 1.4 by 7, right? 1.4 divided by 7 is 0.2. So it's just a little more than 0.2, like 0.21, right? So the height is negative 0.21, about. And that's the height of that. Just rounding, right? So negative 0.21. Well, what that means is this box then, that's negative 1 there. So negative 0.21 is right about there. So there, this area here holds negative 1.5 area, right? That's 0 there. And that's negative 0.21. So that's, if we think about that, right, that's the average height or average y value of this area. So if I add up all the area here from x equals 1 to x equals 8, it's negative 1.5. That's the overall, the net area. And now what I need to do is recognize that I'm putting it into a rectangle with a width of 7, because the distance from 1 to 8. And I have to figure out what's the height of that rectangle. Well, the height of that rectangle is the average y value, right? It makes sense. It's the average y value. So the average y value is negative 0.21. Okay, the average. So if this was a snowfall example, even though it snows and rains, right? So if we looked at this, snowing, 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 still snowing, 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 switches over to rain, 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 rain. Even though there's snow and rain, the average rate is negative 0.21 centimeters per hour. So on average, the snow melts. Okay, on average, the snow melts from 1 to 7, or 1 to 8. Okay, so what's the process? Get the total area under the curve. Okay. Figure out how wide the section of curve is, and then figure out the average height, okay, for that area. And then you'll have the average y value. And the formula, so if we think about it as a formula, we're going to develop a formula here. So if I have an area here, so I'll do this specific example. Our area was equal to the integral from 1 to 7, f at x, or 1 to 8, sorry, f at x dx. This was x equals 1. This was x equals 8. And this base, or the width of that equaled 8 minus 1, which was 7. This we're going to call y average, or f average, ABG. And I know that, oh, by the way, what's another way I can write this? X equals a. That was a in the integral, right? Look at this. 1 is a in the integral, and this 8 is b in the integral. And this 7 is nothing more than b subtract a, because I'm getting the distance from a to b. And then that's y average. So in our case, we have that y average multiplied by this 8 minus 1, which is 7. Or can I write it as b minus a? I think I could. Okay, that's the width of that rectangle. And then that's going to equal this area, which is just the integral from a to b of f of x dx. If I want to isolate for y average, I just need to divide both sides by 1 over b minus, or by b minus a. Now, the way that the formula is usually written is this: 1 over b minus a, integral of a to b, f of x dx, because we know that multiplying by that is exactly the same as dividing the whole thing by that. Excuse me. Now, what I think, I prefer actually having the b minus a right there, and then not having to worry about that. Even though you'll see the formula written this way, it doesn't mean that you have to use it in the form that this is given. You can just calculate that area and divide by b minus a. And again, it doesn't matter if you use y average or f average. Okay, let's apply this rule now. So we're going to get the average y value between x equals 4 and x equals 12 for the graph that we've been using for the last little while. So what I did is I looked at all the different areas. Okay, I looked at the different areas that we've got. So I'm going from x equals 4 to x equals 12, and I want to get the average y value. And if I look, so I've got negative, 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 so snow would be melting all the from 4 to 8 hours, and then from 8 to 12 hours, snow is falling. So the average is probably going to be close to 0 would be my guess, but it won't exactly be 0. Now, again, some things to simplify. Negative 4, positive 4. That cancels out. You add positive 4 and negative 4, and you don't have to, that's going to be 0. So let's just apply our formula directly, okay? So f average, which is y average, right, equals 1 over, b minus a. So by the way, a is 4 and b is 12 because we're doing the average between 4 and 12. So 1 over 12 minus 4, and then I have to get this area, okay? Well, that area is just going to be positive 8, negative 6.43. 8 minus 6.43, which is going to be 1.57 over 8. Okay, 1.57 over 8. And that's f average. Now, to get a decimal to that, 1 over 8 is 0.125. 2 over 8 is 0.25. So I think we're looking at around 0.17 would be my guess. Okay, so f average, I'm just estimating here, is going to be about 0.17. Okay, that's the average y value. So let's go over to here and see what that looks like. Okay, so I'm going to draw a rectangle from 4 all the way to 12. And I think it's going to be about 0.17, so it's just a little bit above, like so. Now, the area in that box, is 1.57, pi by 2. Ooh, actually, so that's pi by 2 over 8, which is pi by 16. 3.14 divided by 16. Okay, so it's pi by 16 is exact then for that y value. Okay, so the area is 1.57, and we know that the y value that's needed to have that area when the width is 8 from there to there is about 0.17. So that's the average y value. Okay, the average y value is 0.17, okay, which we call f average or y average. Okay, so application of the formula is very, very direct. I noticed in a lot of textbooks they just use the formula and apply it. It's not even really developed. But I think it's important that you understand that you're simply taking the area between the curve and the x-axis for all of this region from 4 to 12, and then you fit the net area. Because this looks like, if you look at this, right, it looks like you've got a big area. And you kind of do, except it's negative and positive, and these are very close in size, right? They're very close in size, which means your overall area is just 1.57 pi by 2. So it's actually quite small. So I take this whole area here, and I fit it into a single rectangle. A single rectangle. Okay, between 4 and 8, because that's where the x values I'm interested in. So that area there, it's weird, to think that, but the two yellow areas there are actually equal. So that area is equal to that area, because our areas are signed, positive and negative. This is a net area, right? And then I know that it has a width of 8 because I was doing it from 4 to 12. And then if I want to get the actual height, I just take that area, which is 8 minus 6.43, and then I divide by that 12 minus 4, which is 8. Okay, so it's about, I should have an approximate symbol there. That's approximately, and then exact would be pi by 16. Okay. So again, you're taking the whole area in your original function, and then you're fitting it into a single rectangle, and then getting the average y value. Okay. So again, a very handy little tool. When they do average temperature over the course of a year, that's exactly what they do. Okay. So if you think about that for a second, so you take, there's 0. And if you take, so the temperature, say on average is say -8 in the winter in Belleville, and then it would go up and then come down again, something like that. How do you get, because you get an annual average, right? It'll say the average is 10.3 degrees for a year. Well, how do they do that? Well, they simply do this. They take that area. They take that area, which is going to be a negative. They take that area. And this is like 365 days, right? And then up here, that is maybe, I don't know, 25 in the summer, 24. And they get an overall area, they get that total area. And then they put it into a single rectangle. And it works out to be an average temperature, say, of 13 degrees, maybe over the whole year, okay, for the city of Belleville. That's how the weather network, that's how that data gets calculated, okay? Someone has to understand calculus to do that average, okay? Because anytime you have a nonlinear relationship, the only way to do this is with calculus, okay? So the next time you see, you see something like the average temperature in the month of January even, someone has taken all those averages. They don't just add them together and divide by the number because it's nonlinear, right? They can't do that. You can't just say, like for your 365 days, you can't just add them up to 365 degrees or temperature records and divide by 365. You can't do that because it's nonlinear. Okay, it's nonlinear. So they have to use areas under the curve. And there's one simple, there are many, many, many examples where it's used in a real life situation. Okay, folks, so you've gone over enough stuff now. It's time for you to start doing the work that you'll hand in to demonstrate that you're ready to do the assignment. Okay, good luck.